Welcome to the R video tutorial on artificial neural networks in R. So here we're going to keep on using the Keras approach that we were using last time. This video is going to assume that you have Keras and Python set up on your computer and you've watched the previous video on how to do the data setup. So if you haven't watched those yet, you might want to jump back there. We've talked about neural net, RS, NNS, and ANN2 as other packages that will do artificial neural networks. However, Google's TensorFlow package is amazing, and we want to use this cutting-edge package to see how well we can build really complicated neural nets. All right, so we're going to use the Pieman Dataset again. We used it in the last video, so you should have it downloaded. If you don't, there's a link in the description below that will take you to it. Here's what the data looks like, and remember, we're interested in V9, which is whether or not they have diabetes or not. Here's the model, or here's the setup that we did last time. We normalized all the variables, and I made this function that puts all the variables between 0 and 1 so that it can train the model faster. Instead of having things that have huge magnitudes, everything's now a small magnitude. All right, here's the model from last time. It was an ANN 8-100. So it has 8 units or 8 neural nodes in the first layer and 100 in the second layer. We have a reticulated linear unit in the first layer and sigmoid in the second layer and sigmoid in the last layer because it's going to be between 0 and 1. So let's make this a more complicated model. So what I did is here, I took the last model and I added a dropout layer, and this allows or forces some of the nodes to have 0 weight because maybe they're not needed. And I said let it have up to half of them fall out, have no use at all. Okay, then I added another layer that has 100 units in it, or 100 nodes, and this has the activation of sigmoid and again sigmoid as well. So this is a much more complicated model than our last model. Here's the summary of the model before we fit anything. Notice it has 11,173 parameters. This is a ridiculous number of parameters, but if it works, who cares? Okay, we're going to compile the model just like last time. Again, binary cross entropy because we have a binary response. This is exactly the same as last time. Cut and paste this. We're going to use 1,000 epochs again because why not let it train a lot? It doesn't take that long to run. All right, so once I've ran this is the picture that I'm going to get. You can see the loss function. It comes down and seems to be generally keeps decreasing, but the accuracy kind of plateaus here, and we end up with 78.1% within sample accuracy. Now remember, we did a holdout sample, so we're going to check against it. So here, when we check against the holdout sample, we have, again, 78.1% accuracy, which I find kind of interesting, but it came out exactly the same. And here you can see we had 216 correctly classified as not having diabetes when they don't have diabetes, 84 correctly classified as having diabetes when they did, 39% or 39 people were classified as having diabetes, or no, these had diabetes and we classified them as not, and then these people did not have diabetes, but we said they did. All right, so how did we do since last time? So the last model, this was the results from last time. So we fit an ANN 8-100, and this was the answer, and we had a 79.6% accuracy rate. And with our new model, we had a 78.1% accuracy rate. So we didn't do better. Much more complicated model. If you look, I think there's like 10,000 more parameters than the last one. And it didn't help us out at all. So maybe we could do better. So that's what I'm going to ask you to do in your homework if you're taking a class with me. So what are our options? Well, we could add more layers. We could add different number of nodes to each layer. We could add more dropout layers. We can change the activation functions in each of the layers. So you can have hyperbolic tangent, again, reticulated linear unit, softmax, linear. This is an exponential linear unit, and there's sigmoid as well, which we used before. There's lots of others. Just Google it and you'll find them. All right, so we're going to see if we can do better than this in class, but next time we're going to look at linear outcomes or continuous outcomes. So see you there.